Hello everyone, welcome back to my channel. Today we're going to be doing something a little different. This is the final project for Introduction to Deep Learning, course CSCA 5642. So let's get started. So before we jump in, let's just go over the goal of this project, which is to basically analyze. So we have a bunch of chest x-ray data and we have these images, and what we want to do is make predictions and categorize the process of analyzing the data set from the source, which is an NH, right? So this, again, it contains images and different diagnostic labels and patient metadata and medical imaging. I left the link in the GitHub repo. You guys can check that out. But let's walk through exactly how we did it. So again, this is the overall goal, is to basically predict and detect different diseases in chest x-rays. Okay, so let's jump into the EDA section, exploratory data analysis. So obviously we want to load the data, and just to get a sense of the structure of the data and how it works. So this is just a CSV file, right? And there's over 100,000 records in this, and we have all these different rows, and they represent, so one row for one x-ray. And so basically this is just printing the structure, and then we have some data cleaning here. So sometimes column names can have hidden white spaces, and it can cause like all kinds of problems down the line when accessing them later. So I basically just stripped all of them. So any trailing white spaces, you got rid of them just to make them consistent, right? Just formatting things. So moving on, this is the part where we split the diagnosis labels, sorry. So each image can have multiple diagnoses, and they're stored in this kind of a string that's separated by a pipe. So basically we convert this into a list of conditions per row, which allows us to analyze the data easier. Okay, so this is actually a list itself. So this is the column, and each row contains the actual condition. Okay, so the disease itself. Okay, so then obviously we want to count the number of pathologies. So we gather all of them, and then we use this like a hash map to tally up the disease itself, and then the how many times it appears, right? So we're going to find the max of this dictionary's values to get the most frequently occurring disease. So next we have different patient demographics. So obviously we don't want to count duplicates. Each patient has to be unique. The patient ID is unique, aka it should be like a key in the hash map. And then basically we wanted to examine the distribution of the gender and also remove all kinds of age outliers here. Basically, like if someone is below 1 or above 100 in terms of age, to ensure data equality, because obviously that's an outlier. That's what this conditional is doing. And after that, basically we want to just handle missing values. And yeah, so then this is just validating the image paths to make sure that each entry has an image in a separate folder. So basically each image in the CSV has its own directory. And if not, I basically flag those as missing so that we can model it correctly, so we don't have missing or incomplete data. Okay, so after this, obviously we want to plot the data and visualize the distributions. So we want to visualize the age, the count. So, sorry, the age and the gender, and then also the count. Okay, so basically, if you look at these plots down here, you'll see the patient distribution and the age distribution, and it basically just tells you that certain conditions are more common, right? You just have to read this chart. For example, in this case, infiltration was more common than, let's say, fibrosis. So looking at these charts, this is a correlation matrix between age and pathologies. So what I did was I converted each condition into a binary column, so zeros and ones. So one if a patient has a particular label, and then I basically calculated the correlations between the top 10 most frequently occurring conditions and also the age of the patient. So basically this heat map just shows which diseases are related to exactly which age, and basically just made it easier to guide feature engineering in the future. Okay, so let me see where I was. Okay, so last but not least, this is the pixel analysis, where we know that pixel values can be skewed, like the spacing values of the pixels. So I just wanted to sort of standardize them. So if the data is skewed, just helps to pre-process it and normalize things so that when we do the training down here, it can perform better. Okay, so now to the main part of the project, 65 points. This is the training part where the goal is to predict if a chest x-ray, again, that's the overall goal of this project. We want to see if chest x-rays are normal or bad, basically disease or not disease, using both our images and our patient metadata. So again, this is just some data pre-processing. We need to process the x-ray data set, and then here we scale things, and we basically allocated 20% for testing. And here's just the image directory. This is basically my local directory, and basically just compare different models. So for example, CNN and tabular features. Basically, CNN branch extracts features from x-ray images. Okay, and then the tabular branch, that's job is to process the age and sex, aka the gender, with dense layers. And this is just some input branches, and then we want to combine both the CNN and tabular features and compile the models. So I know this looks a bit confusing, so I hope these comments help. And then this is where we're training the model, and basically we use an atom optimizer and categorical cross entropy loss. And I trained for 2 epochs because, first of all, my laptop was getting really hot, and also, yeah, so basically that was the main reason. And batch size is 32, so this was originally like 20. I had to reduce it. And the accuracy was trained on both the training data set and the validation data set. So yep, that's pretty much it. And here we just have some extra plots. The loss over epochs and accuracy over epochs. You can see the graph is pretty linear. And yeah, so, and then here we compare the models and their performance. And basically you can see the loss and the accuracy. Again, I only did 2 epochs. So yep, that's pretty much it. Thank you for watching, and stay tuned for more.